going to talk about repeating decimals. Repeating decimals are considered rational numbers. So a rational number is one that can be written as an integer divided by an integer, what we normally refer to as fractions. So there are some repeating decimals that we all pretty much know. We know 0.3 repeating 0.3333 forever is the same as 1/3. Most of us know that 0.66666 repeating forever is 2/3. But what about other repeating numbers? How can we determine what their fraction is? This is a little way that we can do it. Let's, for example, take 0.7 repeating. The little bar means that it's repeating. So what fraction is 0.77777 forever? And we're going to reduce them if they're not already reduced. So the way we start is we let x be equal to the number that we want to rewrite as a fraction. So in this case, I'm going to say x is equal to 0.7. Our first step is to multiply something by both sides so that we get the decimal right in front of the repeating part. Well, notice in my first two examples, I already have that down here. In my third example, I don't. So in this step, I don't need to go any further. The second step is to count the number of digits that are repeating. So in this case, I have one digit repeating. It's the 7. So one digit, I'm going to multiply the number of digits by 10 and multiply both sides of the equation by that. So in this case, I have one digit times 10. So I'm going to multiply the whole thing by 10. So on the left, I'm going to get 10x. And on the right, I'm going to get 7.7 repeating. I'm going to take the one above it and subtract. So notice when you just subtract decimals, you line up the decimal places. So I'm just copying the one from above. I'm often lazy, just draw a line and say I'm going to subtract. But in this one, I'm going to show how it's lined up. So 10x subtracted by x, which is really 1x. So 10x minus 1x is 9x. Notice the 0.7 repeatings give me 0. So all that leaves is the whole number 7. Then to solve for x, just divide both sides by 9, and I get that x is equal to 7/9. You can try dividing 7/9 by hand or in your calculator, and you'll see you get 0.777 forever. All right, let's try this one. X equals 0.45. Repeating, which means 0.454545, right, forever. I already have the decimal right in front of the repeating part, so I'm going to count the number of decimal places, which in this case is 2. So 10 times 10 is 100, or you can think there's 2 zeros. We'll multiply both sides by 100, so I'm going to get 100x equals, so decimal's going to move over 2 places when I multiply by 100, 45.45 repeating. I'm now going to subtract that original one lining up the decimals, 0.45 repeating part, and I'm going to subtract. So 100x minus 1x would be 99x. The 0.45s give me 0, so that just leaves 45. Divide both sides by 99 to get 45/99. Both of these numbers are divisible by 3. So I'm going to divide 45 by 3. to get 15. All right, so that'll give me 15 over 99 divided by 3 is 33. Oh, look, I can do 3 again. So notice I could have done 9 to begin with, which would have been fine. But as long as I get there, so 5/11 is the rational number written in fraction form that 0.45 repeating is equal to. All right, what about 0.328 repeating? The 8 is the only one repeating. So I'm going to do x equal to 0.328 repeating. I want the decimal to be right before the 8. So that means I'm going to have to multiply both sides by 100. So I'm going to get 100x equals 32.8 repeating. So again, there were 2 decimal places. That's why I multiplied both sides by 100. Get the decimal right before the 8. Now there's only 1 repeating, so I'm going to multiply everything by 10, which is now going to bring this to 1000x, and this to 328.8 repeating. I'm going to subtract previous line, the 100x, 32.8 repeating. Again, make sure you line up your decimals when you subtract. So 1000 minus 100 is 900. And then 328 minus 32, because what's going to happen with 0.8s is they are going to give me 0 again. So 8 minus 2 is 6. Borrow 1, 12 minus 3 is 9. And then bring down the 2. And divide both sides. So 296 divided by 900. And I can reduce that. I know 4 goes into both of them because 4 goes into 96. And 4 goes into 900. So 296 divided by 4 is 74. And 900 divided by 4 is 225. Let's see, that is got 4, 9. So 9 will go into there, 3 will go into there, 74, no, I don't think, yeah, 2 will go into it, 37, that's a prime number. So this is reduced, and that number, fraction number, is equal to 0.328, repeating, repeating, repeating. All right, let's try this one. That's got a number in front of the decimal. We don't want to let that number in front of the decimal bother us. We're going to do it the same way. We need to have the decimal in front of the 0.36. So if we multiply both sides by 10, that's where the decimal is. We have 2 decimal places that are repeating, so we're going to multiply both sides by 100, giving us 1000x is 1236.36 repeating. We're going to subtract this same line, the 10x. Again, we're going to line up those decimals so that we get 0.36's to cancel each other out. So when we subtract 1000 minus 10, we get 990x. And on the right, we get 6 minus 2 is 4. 3 minus 1 is 2. Bring down the 12. Those, of course, are 0. So x is 1,224 over 990. And that reduces to 562. I just cheated there, put that in my calculator. 562 divided by 495. So that's dividing everything by 2. All right, I'm going to end with an interesting little example, which is 0.9 repeating. So if we let x be 0.9 repeating, which of course is 0.99999, 9's forever, we get 10x, multiplying both sides by 10, was 9.9 repeating. Multiplied both sides by 10. So again, we're going to subtract. So I get 9x equals 0.9's cancel, and I got 9. Divide both sides, and I get 9 over 9, which is 1. So yes, it's true. 0.9 repeating is actually equal to 1. And that is how we convert repeating decimals into fractions.